So what evidence is there that the climate is changing and we have global warming from the point of view of the cryosphere? So again, let's look at the permafrost. In purple, we can see again the distribution looking around the North Pole. So this is a view looking towards the North Pole in the center of the image. And we can see in many places, again, permafrost doesn't necessarily have ice or snow covering it all year round, but the ground is frozen. And we're starting to see strange phenomenon, especially in places like Alaska and Siberia, where the trees are starting to look like they're drunken forests. They're falling over. The houses, which were built in solid ice, so that was very stable, are now starting to fall over and wobbling and collapsing. So we're seeing a lot of phenomenon happening which are related to the thawing out of the permafrost. If we look at how mountain glaciers have changed over time, we can see that people have taken photographs of the glaciers over the last decades, even hundreds of years. And we can see here on the top the Columbia Glacier from 1980 to 2005. The camera is not exactly in the right position, but you can see the arrows, which are here on the map, which show the location of the peaks, the same peaks. If we look below at the Arapaho Glacier, 1898 and 2003 in the same location, you can see the retreat of this glacier. And there are many, many pictures you can see online. The Pedersen Glacier in Alaska, 1917 compared with 2005. And there are many more you can find online, including satellite images. You can see here the Alsek Glacier in Alaska from 1972 to 2019. And you see here, even though the satellites were different, and so the quality of the images are slightly different, you can see that these glaciers, although they continue to flow, if you look at the animation, you'll see that the different stripes in the glaciers are moving towards the ocean, but the extent of the glaciers, how far they move into the bay at the bottom, is decreasing, and you can see that every year that we have a retreat of how far these glaciers are moving into the bay here. So we're seeing this everywhere around the planet, that the glaciers are getting shorter, they're getting thinner, and this can only be explained by the air temperature getting warmer. Again, we saw this before, but if we look at the glacier mass balance, basically all around the planet on an annual basis, we can see from the 1970s until today, we're having thinner and thinner glaciers, ice sheets. It's only going in one direction. We can see this animation now of the sea ice on the annual Arctic sea ice when we have the minimum area, which is at the end of the summer, so August or September, where we have the maximum melt. And you can see here the units are in millions of square kilometers, and how this varies from year to year. So we have also weather patterns. Some years are colder, some years are warmer, but generally you can see the trend is decreasing over time, and it's maybe even accelerating and getting worse as a function of time. We're talking about a change here from in the 1980s, which was about 7 million square kilometers, the summer extent of the sea ice, to closer to 3 or 4 million square kilometers by 2020, 2022. And the rate of this decrease, so this is showing for September, which again, we have the minimum extent. We're seeing a change of about 12.6% for every decade. And if we look at the slope, this green line, this is about 72,000 square kilometers lost every year in the extent, the area coverage of sea ice at the end of the summer, when we have the minimum extent of the sea ice. Now, the sea ice grows back in the winter, and we can see here the annual cycle. So we're going from January to December. In the winter, we have the maximum extent. We saw this in the maps earlier on, but this melts, and in the summer, again, we have the minimum. And the different lines here are for the different periods. The blue dotted line is the average from 1981 to 2010, and we see that nearly every year we're having, both in the winter, but mainly in the summer, less and less coverage of sea ice in the Arctic. So this is definitely a trend we're seeing, and it's related to the warming of the temperatures in the Arctic. In fact, the Arctic is warming a lot faster than the rest of the world. And if we look both on the line plot on the top but also the bottom left, you can see the actual trends of warming in the Arctic, where we see that all the regions are yellow-orange and the reds are up to about 1 degree per decade. And if we compare this to the global warming on the right and also the line plot on the top, we can see that in the Arctic, it's basically 4 times, 5 times the warming that we're seeing on the global scale. And we can see that also with the trend line in the graph, that the slope of this line for the Arctic is much steeper than the global trend. And the reason we're seeing this is because of what we've spoken about, these feedbacks of the snow ice albedo feedbacks, that because we're having this melting of the regions which are normally white in color, white, high albedo, reflecting most of the sunlight, but as they melt, they're absorbing more solar radiation, warming up the waters and the land much more fast and causing more melting and more absorption of solar radiation. And therefore, we get this amplification of the global warming relative to global warming, this amplification of the warming in the Arctic, which again is 4-5 times larger than what we're seeing on a global scale. Now, not only the area coverage is changing, but also the thickness of the ice. And here we can see 2 maps from September 2011 and September 2022. In fact, we've got data going back much further, even in the 1950s, 60s, because during the Cold War period, the Americans and the Russians had submarines which went underneath the sea ice, and they could actually measure how thick the sea ice was from below. And we know then for over decades that the sea ice is getting thinner and thinner. And if you look at the units here, we're talking about meters, something like 2.5 meters, the green, 3 meters, so not that thick. We're talking about a number of meters of thickness of ice which is floating on the oceans, compared with kilometers of ice which is sitting on top of Greenland and Antarctica. But just in this period here of 10-11 years between 2011 and 2022, we can see on the maps here that the regions are still continuing to get thinner and thinner. When the ice is thinner, it means it's much easier to melt it eventually. Even if it grows back in the winter, the next winter it'll be thinner and eventually this ice will disappear. If we look at Antarctica, the signs of global warming, we've also seen this before, but if we look again using the satellite, the gray satellite, which is monitoring the mass, what's pulling on the satellite from, say, 2002, the launch of the satellite, we can see here that we're having a rate of about 150 billion metric tons, gigatons of water, which are lost every year since 2002. And this is the water which is causing sea level rise, is flowing into the oceans.